word on this thing. Or calculus. Okay. So how are we going to do number one? One moment. 1 second. Let me open up my drawing also, and I can put it underneath it. What do we know about functions and their first derivatives?
That.
If a function is increasing, what does its first derivative have to be?
I'm not really knowing what a derivative means.
Wow. Well, maybe that's not what they want you to do here. You haven't had derivatives yet. You had limits and that was it?
I don't know if we used the word derivative. I don't know.
It would be strange that they want you to take how in the world do they want you to solve this? Let me think for a second. If there's a pre-calc way of solving this. Can you use your calculator on this? Is this homework or is this practice for this is final exam review? Would this be a problem that you could use your calculator on or not?
I don't know. Let me look. Hold on. I have the answers. So.
Well, if we can use a calculator, then we can graph it and figure out where it's increasing, right? Okay. In fact, you look at that and I'll pull up my calculator and graph it. In other words, if you were in calculus, the best way to answer this would be to take the first derivative, and wherever it's positive, that's when it's increasing. But in our case, since you haven't had calculus, we got x squared divided by x squared, x squared, was it minus 36?
Yeah.
Okay. Well, if we can graph it, then tell me where it's increasing.
It would be
now
increasing from.
Incidentally, these two graphs you're looking at here, just different scales. In other words, the part you're seeing here is just this part right here. There's two other parts. In other words, look at the bigger scale.
So it would be increasing from negative.
Go ahead.
It would be increasing from.
Start from the far left, because we're defining the x-axis.
So it would be from negative infinity.
Okay. What's this vertical asymptote right here? Where is that?
6.
Okay. So it's increasing from negative infinity to 6. Is it with a bracket or with a parentheses?
With a bracket.
No, it can't be 6.
Oh.
So it's parentheses. If it could be 6, it'd be a bracket, but it can't. In other words, we have a vertical asymptote at minus 6 there. So there's no way the graph can ever be at minus 6 or plus 6. Okay. So it's increasing from negative infinity to 6 parentheses, and then where else? How about this bottom?
6 to infinity?
It's not increasing that whole way. It stops increasing right there and starts decreasing. So 6 to what?
0? Okay.
So that answer is
C, right?
yeah. From minus,
I think we would have to graph that to figure it out.
minus 6 to 0. Not 6, but it's minus 6 to 0. Well, yeah, I don't know how else they would want you to figure it out other than graphing it. If you had calculus, there's a real easy way. You take the first derivative, and wherever it's positive, that's where the function is increasing. But I don't know if that's easier or not, but it kind of answers to me that we have to graph these. What kind of calculator do you have?
TI Inspire.
Okay, unfortunately I don't have that one on my desktop. I've got a TI-84, but as long as I don't have a virtual Inspire, then let's graph them on Wolfram Alpha. Let's see, hold on a second. Let me just graph these as we come to them. What is this? X cubed divided by 9 minus x squared plus 1. Now, you don't have any problem graphing these on your calculator, right?
No, not at all.
Okay. Because I have an Inspire, it's just in my briefcase. It's not on my on my desktop, so it's hard.
Right.
But as long as you know how to do it, that's all that's important. Okay, so looking at this graph, where are we increasing?
Increasing would be from...
Oh, I'm sorry. They ask about decreasing. Where is it decreasing?
It decreases from... would it be... Huh.
Where does it start decreasing on the x-axis? In other words, when you're defining where a function is increasing or decreasing, forget y. What you're defining is along the x-axis, I'm going to tell you where the function is decreasing. Well, it starts decreasing right there. Where is that on the x-axis?
0.
Brackets or parentheses?
Brackets.
Right, because it can be 0. Where does it stop decreasing?
6.
Brackets or, yeah.
Brackets.
So it's this one. It's B. The only other choice would be C, which is 0 to 6 with parentheses around it. But do you have answers on these?
Yeah, but I'm not looking at them.
Look at this one. Just make sure that it's B.
Okay.
I just want to satisfy myself that it's not C.
Yeah, it's B.
Okay. So if it can be that number, in other words, it's not really decreasing until you get to the right of 0, right?
Right.
So that's why I was questioning it. So that answers it. Okay. This one here, which of the following is a vertical stretch of this function by a factor of 3? Well, we don't need to graph this. If f of x equals whatever it equals, and I vertically stretch it by a factor of 3, what do I want to do to f of x? That means that.
Okay.
In other words, if I multiply in front of the function by a number, that's a vertical stretch. So I'm going to do 3 times f of x, which is 2x to the 4th minus x squared. Just carry out that multiplication, and whatever we get, that's going to be our answer. D.
Okay, so D. Yeah, and it is D, based on the answer.
Yeah, no, that one I knew for sure. Okay, these get a little bit different. What is required here is not so much the answers as knowing what a vertical stretch means. That means a vertical stretch. What does a horizontal stretch mean?
It stretches horizontally, so you do 1/2.
That would be a vertical compression. If I get 1/2 of f of x, in other words, anytime you put a number in front of the function, it's always a vertical thing. The only difference between these two is this is a vertical stretch, this is a vertical scrunch, or whatever you call it. What do you call it?
A vertical compression.
Compression. Okay, I'll try to remember that. So we have vertical stretch, vertical compression. Vertical stretch, this number is greater than 1. Vertical compression, this number is less than 1. Okay? So, when we're talking horizontal, we're talking, so I'm going to put a C there and call that vertical stretch. Okay? If the C is in front of the X, like this, that's horizontal. That is a horizontal stretch if C is less than 1, and it's a horizontal compression if C is greater than 1. Notice it's the opposite of the vertical. In the vertical, it's a stretch if C is greater than 1. Well, horizontal, it's a stretch only if C is less than 1. So they're looking for a horizontal stretch of this function by a factor of 2. Well, if f of x equals x to the 4th, if I want to stretch it by a factor of 2, I'm going to figure out what f of 2x is. What's f of 2x?
Would it just be 2x to the 4th?
Which answer?
B.
Good. Because A says the same thing, but it's the quantity 2x to the 4th. In other words, there's a difference between A and B here. B, the 2 is taken to the 4th power also. But the way you solve this is just to plug in 2x wherever you see x. So 2x quantity to that 4th power. Okay? All right, I'm going to leave that list up because this is very helpful. And the only way to figure these out is to know this. And not everybody knows this. A lot of people know there's 6 transformations, but they don't know exactly why. Well, we need to learn these here. Okay, so we're looking for a vertical shrink by a factor of 1/4. So what does our function need to look like? If f of x equals square root of x plus 2, and we want a vertical compression, shrink.
So
we use shrink. Shrink and stretch are the 2 words. We also have vertical shift, which moves everything up or down without changing its shape. But stretches and shrinks change the shape of the graph, as do horizontal stretches and shrinks. So if I want a vertical shrink, what do I do?
It would be B, right?
Correct. In other words, you put a number in front of the function, and it's got to be less than 1, and since it's by a 4th, it needs to be a 4th.
Okay.
All right. Horizontal shrink of the absolute value function by a factor of a 5th. What do I need? F of what?
5x.
Good. What's that? Which answer is it?
D.
Correct. Is B and D the same?
No, because 5 is inside the inside the thingies. I don't know what to call them.
Absolute value sign. But they are in fact the same.
They are.
In other words,
Okay.
no matter what value you put in for x, this is going to be the same as that because 5 is always positive. So I can remove it from the absolute value sign. In other words, put in a value for x. If I put in a positive number, they're definitely the same, right?
Yeah.
Okay, we'll put in a -2 for x. What's this equal to?
B or D?
No, what I just circled.
Oh, a -2, so it would be 10.
What would this be if x is -2?
Still 10.
Correct. That was all I was trying to point out. That whether
So it could be B or D, right?
Exactly. Shame on them for putting an ambiguous answer in there.
Okay.
I'm guessing that your answer is D.
Okay.
Merely because that follows the pattern properly. But the fact is you can take that 5 outside. As long as it's a positive number, you can take it outside the absolute value and it doesn't change anything.
Yeah, it says it's D on my answer key.
Yeah, that's because the way we do it is this way over here, and that translates directly to that. It just turns out that once you get it to there, you can remove that 5. I don't suppose you have to, but you can. Okay, which of the following equations best fits the graph shown below? Well, what can we see about that graph down below? Does it have a vertical asymptote?
Yeah.
Where?
At 2.
No, the vertical asymptote.
Vertical asymptote's at 3.
Negative 3. So that eliminates A. What are our possible answers if we have a vertical asymptote at -3?
Would it be C and D?
Right. Those are the only two possibilities. Both of them are shifted up by 2 units. So which one is it? Is it C or D?
I think it's D.
It's D. Because of this negative sign. Let me show you why. If you have a typical hyperbolic function, that's your basic hyperbolic function. Has a vertical asymptote at x equals 0, asymptote at y equals 0, it graphs in the first and third quadrant. If I put a negative in there, it switches it to the second and fourth quadrants.
Okay.
Now, with simple functions like this, you can make that leap. With more complicated functions, you can't necessarily. If I say, well, let's take this function here. There's no negative signs in front of it. Do I know if that's in first and third or second and fourth? Personally, I don't know. I would have to plug in some values and check. Okay, but up here, this is a very straightforward function. It's 1 over x plus 3 plus 2, but if it was this one, it would be in the first and third. In other words, it would be up here and down here. Can you see what I'm saying by second and fourth?
Yeah.
That means there's got to be a negative in front somewhere. Or it does as long as the numerator is just 1. If it's more complicated like this, it's harder to figure out. But if it's really basic like this, you know that just looking at this thing, I got to have a negative sign somewhere in this thing.
Okay.
All right, let's see. We got time for another one here. Let's finish this page. Which graph below is for the function e to the x minus 2 minus 1?
So it's horizontally shifted, right?
Good. By how much? And which way?
To the right too.
Good. It's a horizontal shift.
This is like the only stuff I'm good at.
Okay. And what's the consequence of the minus 1? In other words,
I'm not sure.
well, here, let's draw the basic curve. I think that's the easiest way to figure this out. In other words, here's our basic y equals e to the x. And the key thing is it always goes through this point right here, 0, 1, if it's y equals e to the x. Okay? Because when x is 0, anything raised to the 0th power is 1. Okay? So, we've got two things. We've got a horizontal shift to the right by 2 and a shift, what's the consequence of the minus 1? Vertical shift down.
Okay.
In other words, when you have f of x plus c, that is a vertical shift, and that's what we're looking at here. Actually, what we're looking at is f of x minus 2 plus 1.
Okay.
Okay? So we're looking for something that's shifted right by 2 and down by 1. Well, let's take our only known point, shift it right by 2 and down by 1. It's going to end up, if this is 2, it's going to end up right there. Which of those curves goes through that point right there?
C and D both do.
On our elementary function, e to the x, we have a horizontal asymptote, right?
Mm-hmm.
So we need that horizontal asymptote to drop by exactly 1. Doesn't affect the horizontal shift, but it does affect the vertical shift. So which one has a horizontal asymptote at y equals minus 1?
C.
That's the answer. Okay? And I know it's 7:30, but I just want to make sure we cover these others really quickly here. I can do it in 1 minute.
Okay.
This is vertical stretch. This is horizontal stretch or shrink. That's vertical stretch or shrink. You already figured out that f of x minus c was a horizontal shift, right?
Yeah.
That's how you figured out that e to the x minus 2 was a horizontal shift to the right by 2. Well, we can also have f of x plus c, that is a vertical shift, and those are the only 4 things you can do except reflections. There's 2 reflections. There's minus f of x. What kind of reflection is that? Over which axis?
Would it be the y?
No, the x. And then there's f of minus x. That's reflect over y.
Okay.
So if we had e to the x, if I had e to the minus x, which is that? Is that a reflection over x or y?
Y.
Correct. But if I had minus e to the x,
it would be over the
there
x.
you go. Those are the 6 transformations that you need to know, and you kind of need to know them in this format, because what happens is when you look at the function, you got to be able to take that function and figure out, is that f of x minus 2 minus 1? And yes, it is. In other words, once you can figure out what that is in terms of the elementary function, then you can figure out that that's a horizontal shift and a vertical shift based on this stuff over here. Okay?
Okay.
All right. Wednesday at 7?
Yeah, I actually work that night, so I will not be able to do
Want to
that.
move it to Thursday, or I would think with your final coming up, you're not going to want to miss too many tutoring sessions, but it's up to you.
Could we do tomorrow at that time instead?
Yeah.
Okay, cool.
I'll put you in at 7 o'clock tomorrow.
Perfect. Thank you.
Okay. I'll talk to you then.
All right, sounds good.
Bye-bye.